Welcome to the Python Basics module. By the end of this module, you should be able to describe the fundamental Python concepts. Python is a very popular general-purpose programming language used in multiple fields. It is an open-source interpreted programming language. The Python interpreter is written in C. The syntax of Python is intuitive and concise, helping you quickly create simple programs. Python has a rich ecosystem with many libraries and modules available to help you develop applications. In many cases, you can solve the task you are working on by simply combining pieces of already existing Python code. Python uses an automatic memory management model. When an object becomes unused or no active references to it exists, the object is automatically deleted from memory by a Python component called the garbage collector. Python supports concepts from structured programming, object-oriented programming, and certain elements of functional programming. Python is cross-platform. Typically, the same Python script functions identically on Windows, Mac, Linux, and other operating systems. Python is pre-installed on most modern Linux distributions. For other operating systems, download and install Python from the python.org website. Why learn a programming language when automation tools like Ansible enable you to perform network automation without having to write code? There are multiple reasons why learning Python is beneficial. A number of Python libraries are available that make network device automation easy. Juno's PyEasy is one example. These libraries transform Python into a powerful tool for automating all types of network tasks. Although tools like Ansible and Salt enable automation without coding, they rely on software modules typically written in Python or a similar language to perform tasks, like configuration uploads and RPC execution. If no module exists for the task that you want to perform, knowledge of a programming language can help you build the module yourself. Even if you don't plan to write Python code, being able to read it is beneficial. It helps you better understand how existing tools work. Python enables you to manage your network infrastructure using code. Python skills are highly transferable. Python skills are useful if you want to perform advanced data analysis, web development, or experiment with artificial intelligence or AI, and machine learning or ML. This is an example Python script. It defines a list of interfaces called myInterfaces and demonstrates using Python if, else if, and else operators in the body of a for loop. Similar to other languages, if, and else flow control operators are used to test conditions and perform a set of operations, if the conditions are met, or another set of operations if the conditions are not met. The starts with method of the string object is used to check if a given string starts with a particular value. Note that strings use single or double quotes. The first clause checks if the string interface starts with GE to check if the speed of the interface is 1G. The subsequent check evaluates if the speed is 10G. Should the interface not match any of those values, the operators in the else statement are executed, causing the code to print the corresponding message. Python uses the hash symbol to indicate comments. Alternatively, 3 quotes before and after the block of code can be used to indicate a multi-line comment. There are some differences in Python's syntax compared to more traditional languages like C or Java. Notice that Python strictly enforces the use of white space or indentation. Because Python uses indentation, you do not have to use curly braces to show structure or nesting of code blocks. Instead, a few spaces or a single tab indicates that the spaced or tabbed block of code belongs to a function or control loop. Note that you are not allowed to mix tabs and spaces in a single Python file. The examples in this module use 4 spaces for indentation. Executing Python code is similar to executing Unix shell scripts. You can call the Python interpreter directly, or, if the path to the interpreter is included in the Python code, you can run Python scripts the same way you run Bash scripts. This flowchart demonstrates the actions that are taken when a Python script or program is executed. When Python code is executed, the Python interpreter analyzes the program or script. If there are no syntax issues, the interpreter begins to translate the Python code to bytecode. In some scenarios, the Python code is translated and stored as a Python bytecode.pyc file. Storing Python modules and packages in this manner speeds up execution because the interpreter doesn't need to evaluate the Python code every time the module or package is referenced. Finally, the bytecode is passed to the Python runtime, known as the Python Virtual Machine or PVM, that executes the bytecode instructions. Python provides interactive interpreter sessions in much the same way that the Junos OS CLI provides interactive sessions with the Junos OS. Start the Python Interactive Interpreter, sometimes called the Python shell, by typing Python for a Python version 2 interpreter or Python 3 to launch a Python version 3 interpreter. If your system has multiple versions of Python installed, you can run a specific Python version by typing Python 2.7 for Python 2.7 or similarly for other versions. Exit the Python interpreter by typing exit or Control-D. Use the interactive Python interpreter to perform the same tasks you do in Python scripts. An interactive session with the Python interpreter is useful for short, simple, and familiar tasks. As tasks become more complex, many developers prefer to create Python scripts that enable the code to be saved for future use, possibly in a version control system or VCS. In this Python interpreter example, two variables, A and B, are assigned values. The values are then printed on the screen by entering a variable name and pressing Enter. Next, a function named f is defined using the def keyword. The function takes one parameter or argument named x. It returns a value of x squared that is tested in the f of a plus b command. Python operators are used when creating control loops and when working with Python variables. Operators are keywords or symbols that, when combined with data objects, form expressions. Expressions are used in Python code to create statements that control program execution. Python supports the following operator types. Comparison operators are useful for manipulating flow control when combined with if, and else statements. Use the double equals operator to determine if two variables contain equal values. You can use the double equals operator to test equivalence between strings, integers, or even dictionaries and lists. The not equals operator checks if two variables are not equivalent. Arithmetic operators are typically used to manipulate numbers. However, in some cases they may operate on other data types as well. The plus operator, for example, is used to add two integers or concatenate two strings. The asterisk operator, although typically used to multiply numbers, can also act on strings as shown in the example. Assignment operators, such as equal, are used when assigning values to variables. Bitwise operators like binary and binary or enable operations on binary numbers. Logical operators are useful for flow control. Membership operators like in are useful to check containment in a collection, like a Python list or dictionary. The Python programming language is being actively developed and new features are being added over time. You should be aware of which Python version you are using. Both Python 2 and Python 3 are currently in use. But Python 2 is gradually and very slowly going away. The basic examples and activities in this module use Python 3, but they typically work in Python 2. Changes were introduced in Python 3 which are not backwards compatible with Python 2 to make the language more consistent. Some of the changes include: the Python 2 print statement has been replaced with the Python 3 print function. The example shows that print of hello syntax works the same with both Python 2 and 3, while some more complicated calls work a bit differently. In particular, in print of hello world. Python 2 treats hello world as a tuple and outputs accordingly. Integer division displays results differently. Python 3 has improved Unicode support. Python 3 strings are always treated as a sequence of Unicode characters. Hence, the traditional Python 2 approach of putting the letter U before the string to indicate Unicode is not used. Consult the python.org website for more details on differences between Python versions and how to write Python code for the different interpreters. Welcome to the Python Operations module. By the end of this module, you should be able to describe how to perform basic Python operations. Python variables are user-defined names that are references to objects that are stored in memory. In the example, a list containing the numbers 1, 2, 3 is created and assigned to variable x. The list object is stored in memory, and x can be used to reference it. The example sets the y variable equal to x, sets 5 as the first character in the list, and demonstrates that x and y are equal. You might expect y to be 5. However, the x equals 5 line actually creates a new object identified using a new ID value in memory. The y variable still points to the existing object ID, representing a value of 1. The key difference between the two examples is that the x of 0 equals 5 operation modifies the existing object, while x equals 5 operation creates a new one. Python does not require you to declare a data type when creating variables. Python determines the variable data type based on the value provided. This example illustrates the use of two different Python variable data types. Using single quotes to assign a value to a variable creates a string-type variable that can be accessed using the variable name. A whole number value without special expressions or syntax is considered an integer. Python represents data as an object, and all Python objects are classified as being either mutable or immutable. Mutable data types, such as lists and dictionaries, can be modified after they have been created. Immutable objects cannot be changed after they are created. Numbers and strings are examples of immutable data objects. This example uses a number object, the number 3. Once the number object is created, attempting to change it displays the output shown. However, a variable pointing to an integer object can easily change its value and begin pointing to a different number object. Python does enforce variable scope, sometimes referred to as namespaces. Each Python script or module has a global namespace. Variables defined in the global namespace can be referenced in any portion of the module's code. Variables defined within a Python module function are only usable within that function. Global variables are usable in any namespace. Python variables are referred to using names. Where a Python variable is defined in a script determines where the variable can be used. Blocks of Python code, such as functions and modules, are assigned a unique local namespace. When a variable name is referenced in Python code, the Python interpreter examines the function's local namespace to try and resolve the variable name. If the variable name is not found in the local namespace, the Python interpreter moves outward to any outer functions, then outward to the module's global namespace. Finally, the interpreter checks for any matching built-in Python module names. Python supports object-oriented programming. Object-oriented programming permits you to create objects belonging to various classes. Each object exposes various methods that permit you to work with the object in a manner somewhat similar to how you work with physical objects. Objects are created using object classes, which are similar to templates. Object classes define the object and all of its properties and methods. A physical world object analogy is an automotive factory that has a template of a truck. When the factory produces truck objects, they use the truck template, not the template for a car. You can create custom object classes using Python. But here, You use predefined object classes from existing Python libraries, like Junos PyEasy. The syntax for creating an object is shown. The truck1 equals truck creates a new instance of a truck object class and saves a reference to the new truck object to the truck1 variable. Object methods are functions that work with specific object class instances. For example, a truck object may have a drive method. The drive method can be called using truck1.drive. In the example, an empty Python list object is created using z equals list. A list is the name of a built-in Python object class. The z variable is used to reference the new list object. Next, the append method of the zlist object is called 3 times to add numbers to the end of the list. Finally, the resulting list is printed to the screen. For classes that are not built into Python, the convention is that class names start with a capital letter. For example, truck, device, and so on. A list in Python is an ordered and indexed sequence of elements. List elements can include different Python data types. List elements are indexed using numbers starting from 0. Indexing can also use negative values, indicating that counting starts from the right with the last element in the list. The in operator checks if an element exists in a list. The Python len function is used to retrieve the list length. Multiple methods are available to manipulate lists. Some of these methods include append, which adds an element to the end of a list; insert, which adds an element to an arbitrary position; pop, which extracts and returns the last list element, removing it from the list; reverse, which reverses the elements in the list; sort, which sorts the list. You can refer to Python documentation for more details on list methods and method parameters. A common programming task is to apply an action to the elements in a list. The example demonstrates performing a nested loop. Someone playing tic-tac-toe recorded the result as a board list, or 3 rows with 3 character elements each. A nested for loop is used to print the data structure. The end equals parameter used with the print function is specific to Python 3 and indicates Python to print a space after the value instead of creating a new line, which is the default. To use the same syntax in Python 2, you would need to import the print function. Another Python data type is the tuple. Tuples are similar to lists and have the following characteristics. Like lists, tuples contain an ordered sequence of values and are indexed starting from 0. Unlike lists, tuples are immutable. Once you create a tuple object, it cannot be modified. However, it is possible to create tuples that contain references to mutable objects like lists. Tuples typically contain a heterogeneous sequence of elements, while lists typically comprise homogeneous elements. For example, a tuple may be returned as the result of a database query because the different database table columns contain different data types. Tuples use parentheses instead of square brackets. A Python dictionary is an unordered collection of key-value pairs. Because of the specifics of how data from dictionaries is stored, the order of keys in a dictionary is not preserved. Hence, the unordered characteristic. This means that when performing a for-each loop over a dictionary's keys, you should not expect to see the keys returned in the same order in which they were added to the dictionary. You can check for the presence of a key in a dictionary using the in operator. The value corresponding to a key can be obtained using key syntax. And if the key is not present in the dictionary, a Python exception is generated. Another way to check for the presence of a key is the getKey dictionary method. This method displays none if the key is not present in the dictionary. To create a new entry in the dictionary, simply assign a value to a non-existing key. To delete a key and its corresponding value from the dictionary, use the del method. Dictionary values can be any data type, including nested dictionaries and lists. Only certain Python data types can be used as dictionary keys. Dictionary key data types must be immutable objects like numbers, strings, and tuples. Lists are mutable objects and do not qualify to be used as keys. Although uncommon, the data types of keys in the same dictionary can be different. There are multiple ways to iterate over the elements in a dictionary. Two options are shown in the example. Remember, the order in which you retrieve the keys in a dictionary using a for loop is generally not the same order in which the keys were added. Dictionaries are also not sorted in any way by default. Python sets are unordered collections of unique elements. Similar to dictionary keys, only immutable objects can be used. In contrast to dictionaries, Python set elements only have keys and no values. Mathematical operations like intersections and difference are supported as shown in the example. Performing an intersection operation on two sets, for example, sets A and B, results in a set that contains all elements of set A that are also present in set B. For example, the intersection of CDE and BDAC is DC. The difference between two sets, for example, sets A and B, results in a set of elements that are present in A but not present in B. For example, the difference between BDAC and CDE is BA. An A.update of B method adds all elements of set B to set A. If an element already exists in a set, no action is performed on that element. Note that the intersection and difference methods return new sets, while the update method modifies the existing set. Welcome to the Installing and Using Python Modules module. By the end of this module, you should be able to explain how to install and use Python modules. A Python module is a single file containing Python code. The module file name is user-defined and typically ends in a .py file extension. Organizing Python code in different modules is useful when similar functionality is required by multiple Python scripts. Python modules can import functionality from other modules, facilitating reuse of existing code. A Python package is a directory containing a collection of Python modules. The Python standard library, included as part of a standard Python installation, has multiple packages and modules that greatly extend the functionality of Python. There is also a public central repository for Python packages and modules called the Python Package Index, or PyPI. Code residing in this repository is well documented and can be used for your own projects to extend Python's functionality. Python has an active developer community, and programmers share code that may be useful for your own projects. Don't look to reinvent the wheel. There may be a piece of Python code that is already built that meets your needs. Modules in the Python package index are not included in the base Python library. The pip utility, pre-installed on many Linux distributions, is used to install Python package index modules and packages. The example demonstrates using pip to install the Python Paramiko package. To use the functionality provided by a package or module, import the package or module using the import keyword, along with the name of the package or module. Once imported, you can reference the objects, methods, and functions defined in that package using the name of the package followed by a dot and the name of a package method. This example demonstrates using an import statement to import the RE, or regular expressions module, from the standard Python library. The Python interpreter is now able to use the match function provided by that module using the re.match syntax. As an alternative, you could use the from re import match statement. This imports only the match functionality of the re module and permits you to reference the match function without including the module name. Welcome to the Executing Python Scripts module. By the end of this module, you should be able to explain how to create and execute Python scripts. You want to use Python to automate the process used to copy a new software image to Junos devices. The new Junos software image should be copied from your management workstation to the /var/temp directory on the Junos devices. To copy a new software image to a Junos device, several actions must complete successfully. Your Python script must establish a connection to a Junos device, authenticate successfully, securely copy the software image file, and finally close the connection. Each action requires instructions in Python code to complete the task. Writing Python code to accomplish each action requires advanced programming knowledge and a good bit of time. Remember that Python supports importing pre-existing modules that add additional functionality to your Python code. The Python script used in this example leverages pre-existing modules from the Junos PyEasy library. These pre-existing Python modules can perform each of the actions required to successfully copy a new software image to your Junos devices. The example Python script imports the device and SCP modules from the Junos PyEasy library. A device object is created representing the 172.25.11.1 device. Using Python Context Manager with as syntax automatically opens and closes the connection to the target device. The SCP object establishes an SCP session with the target device and copies a software image file to the /var/temp directory. The SCP object progress option is included in the script to display output related to the copy process. The example script is run. Remember, the SCP object progress option was included in the example Python script. Progress information related to the secure copy operation is displayed in 10% increments. Let's look at another example. You want to verify whether the software image file was successfully copied to a device. This Python example demonstrates importing and using the Junos PyEasy Start Shell module to execute a Unix ls command on the /var/temp directory on the target device. The results are printed on the screen. The opening and closing of the device connection are performed manually. The Python script is executed demonstrating that the software image is present on the target device.